6.6 linear equations. So this does have something to do with chapter 8, and when we get to example 2, I'll show you why. Alright, so linear equations. The Cartesian coordinate system. The horizontal line is called the x-axis. The vertical line is called the y-axis. So I'll highlight those for us. The horizontal line, which is the x-axis, that's that. And then we have the vertical line, which is the y-axis. And that's this one right here. Nothing new. The point of intersection is called the origin. So this point right here, that's called the origin. Alright, plotting points, ordered pairs. Each point in the xy plane corresponds to a unique ordered pair, A and B. So if we plot 5, 3, we always start from the origin. We go right 5 and up 3. The reason why we go right is because right is positive. So right is positive and up is positive. That means left is negative and down is negative. Alright, let's plot points. So we're going to plot negative 2, 4. So since it's negative, remember it's left or right, then up and down, because it's x and y. So I'm going to go left 2, then I'm going to go up 4, and that's A. Now let's do B. So it's positive 3, right 3, negative 2, down 2. That's our B. Now we have C. Negative 1, so I'm going to go left 1, negative 3, down 3. D is 0, negative 4, so that means we don't move left or right. We just go down 4 units. E, we have 6, so we go right 6. And then 0 for Y, so we don't go up or down. And that's our E. Alright, a parallelogram. This is how it fits into chapter 8, because we are going to talk about parallelograms with this. So the points A, B, and C are 3 vertices of a parallelogram with 2 sides parallel to the x-axis. Plot the 3 points below and determine the coordinates of the 4th vertex D. So you're like, why do we have 2 graphs? You'll see why. Alright, let's just plot the points that we have. So we have 1, 2, so I'm going to go right 1, up 2, and that's A. Then I have 2, 4, so I'm going to go right 2, up 4, and that's B. And then C is 7, 4. So right, I didn't go to 7, just pretend 7's there, and I'm going to go up 4. So we're going to connect the dots, like how your eyes would connect the dots. Wouldn't they connect like this? Wouldn't your eyes see this? So what we're trying to find is the dot that's somewhere over here. Because don't we want to finish the parallelogram? Don't we want to finish it somewhere? So we have to find the dot that somewhere goes here. Now we don't know where it is. We can't assume where it is. So let's try and figure out if we can see where it is. And we use distance. And it's always going to be the same distance. So from B to C, let's find the distance. So it's 1. Sorry, wrong color. So it's 1, 2, 3, 4, 5 units. So this distance is 5 units. That means from A to this invisible point, it's 5 units. So 1, 2, 3, 4. Right here is the 5th one, so that's our point. And that point is right 6, so positive 6. Up 2. So that is our next point, is 6, 2. So we can connect it now. Alright, now let's do the, there is another one. So let's just plot the points again, and I'll show you where it is, and as soon as I show you, you'll be like, I see it now. I totally see it now. Okay, so A is 1, 2. That's our A. Then we have B, which is 2, 4, so right 2, up 4, right, that's B. Then C is 7, 4, so 7, 4, that's C. So where can the other one be? If I draw it out, so if I connect the dots, right, can't I also go this way? Isn't that another parallelogram? So I need to find the hypothetical point that's somewhere in this region. So to find that, I'm going to do the same thing. I'm going to find the distance. So we know here to here is 5 units. So that means the next point, it's still going to be 5 units away, just in the opposite direction. So 1, 2, 3, 4, 5. There's our point. It's at -4, 2. So let me rewrite that. -4, 2. And now we can connect our dots. So after you plot the points, find the distance. You're going to go both ways. So you're going to go right 5 units and left 5 units. Or however many units you're apart. Graphing linear equations by plotting points. A graph is an illustration of all the points whose coordinates satisfy an equation. All equations of the form ax plus by equals c, where a is and b are not 0, will be straight lines when graphed. Thus, such equations are called linear equations in 2 variables. Since only 2 points are needed to draw a line, only 2 points are needed to graph a linear equation. It is also a good idea to plot a third point as a checkpoint. If no error has been made, all 3 points will be made a line or collinear. There are 3 ways in which we can graph a line by hand. Make a t-chart, use intercepts, and use slope-intercept form, which is y equals mx plus b. We're going to practice with all of them. For the test, it's up to you and how you want to graph it. Alright, so let's use a t-chart. A t-chart is just that, it's x and y. And we just pick any x. So the x's I like to pick are -1, 0, and 1. Why? They're small numbers, and I like 3 points. So you can pick any number you want, but keep it small because you have to plug them in. So we have y equals 2 times x, which is -1, plus 2. So 2 times -1 is -2 plus 2, which is 0. Do it again. So we have y equals -2 times x, which is 0, x, which is 0, plus 2. So -2 times 0 is 0, and 0 plus 2 is 2. Alright, now let's plug in 1. So we have y equals 2 times 1 plus 2. So 2 times 1 is 2, and 2 plus 2 is 4. So we're going to plot our points now. We have -1, 0, so -1, don't go up any. Then we have 0, 2, so no left and right, just go up 2. And then 1, 4, so right 1, up 4. And you connect those dots. And there's our graph. Graphing by using intercepts. The point where the line crosses the x-axis is called the x-intercept. The graph where the line crosses the y-axis is called the y-intercept. To find the x-intercept, you set y equals 0 and solve the equation for x. To find the y-intercept, you set x equals 0 and solve the equation for x. So whatever you're trying to find, the opposite becomes 0. Let me point them out on what they look like. That is an x-intercept. -1, 0 is an x-intercept. So you see how y is 0 there? Because the opposite of x is y, so y is 0. And then we have another intercept here at 0, 2. That's our y-intercept because x is 0. So we can graph by using intercepts. So to find the x-intercept, the opposite of x is always y. So we're going to make y equals 0 in our equation. So we have 2 times x plus 3y, which is 0, equals 6. So 3 times 0 is 0, so 2x equals 6. Divide by 2, and we get x equals 3. So that point, because remember a point is xy, so the point is 3, 0. Now we need to find our y-intercept. So the opposite of y is x, so we need to make x equals 0 in the equation. So we'll have 2 times x, which is 0, plus 3y equals 6. 2 times 0 is 0, so 3y equals 6. Divide by 3, we get y equals 2. So that point is 0, 2. So we have 3, 0, so right 3, that's it. And then 0, 2, so up 2, and we can connect those dots. Wow. Alright, slope is the measure of the steepness of a line. The slope of a line is a ratio of the vertical change to the horizontal change for any 2 points of the line. So it's a vertical change over horizontal change, also known as y2 over y1 over x2 minus x1. You might remember this from physics or chemistry. It means change of y over change of x, which means vertical change over horizontal change, which means y2 minus y1 over x2 minus x1. This is the formula we use. This is the one you should study. Positive slope rises from left to right. Negative slope falls from left to right. So positive, do you notice we climb up because it's positive? And when it's negative, do you notice we go down because it's negative? A horizontal line, which neither rises nor falls, has a slope of 0. That's also known as y equals any number. Because you see how it goes through the y-axis? It cuts through the y-axis. That's why it's y equals. The slope of a vertical line is undefined. So this is known as x equals a number. Because you see how it goes through the x-axis? That's why it's x equals a number. Alright, let's determine the slope of this line. The slope of the line that goes through -1, -3, and 1, 5. So since it says slope, we know m equals y2 minus y1 over x2 minus x1. Label your points. So x1, y1, x2, y2. When I'm teaching pre-calc and stuff like that, the amount of people who get things wrong because they don't label their points it's just ridiculous. Label your points, and this way you can go back and see if you're plugging them in right. So y2 is 5 minus y1, which is -3. So we always wrap our negatives. And that's over x2, which is +1, minus x1, which is -1. See how the colors match? Purple or pink? It's purple to me. Purple on purple, green on green. So we know minus in the middle become plus. We have 5 plus 3, which is 8. 1 plus 1 is 2. 8 divided by 2 is 4. So our slope is 4, which is 4 over 1, by the way. Slope-intercept form of the equation of a line, which is y equals mx plus b, where m is the slope of the line and 0b is the y-intercept of the line. So to graph linear equations by using the slope-intercept form, you're going to solve the equation for y to place the equation in slope-intercept form, determine the slope and y-intercept, plot the y-intercept, obtain a second point using the slope, draw a straight line. So let's practice this. Alright, the first thing we need to do is solve for y. So to solve for y, I'm going to subtract 4x to both sides. And when we do, we have -3y equals -4x plus 9. Now we need to divide everything by -3. Remember, math is fair. Math is fair. So we have y equals positive 4 over 3x minus 3, because remember, negative become positive. So now that we have y equals, we can determine our slope and our y-intercept. So our y-intercept is always 0 and number. Your slope is always the number with x. So the number with the x is 4/3. So remember, slope is rise over run. So since it's 4/3, I'm going to go up 4 and right 3. Alright, our y-intercept is always 0 in the number, and it's always the number without the x. So the missing 1 is -3. So our y-intercept is 0, -3. Your y-intercept is always the point you plot first. So 0, -3. We go 0, and then down 3. And then we're going to use the slope. So at the y-intercept, I go up 4. So 1, 2, 3, 4. Then right 3. 1, 2, 3. And we connect the dots. Determine the equation of a line from its graph. Determine the equation. So since we're talking about a line and its graph, we should think y equals mx plus b. So we know b stands for the y-intercept, which is a 0.0 number. Let's see if we have a 0.0 number. So the points that we're given are 0, 1. And another point we're given is 3, 0. So we do have something that is 0 number. Right here, it's 0, 1. So since we have that, we found the b. It's positive 1. Now we need to find our slope. So our slope, we count point to point. So remember, slope is rise over run. So I need to go up 1. And then we go left 3. So 1, 2, 3. So up is positive. So that's positive 1. And left is negative. So our slope is negative 1 over 3. So we just plug it in. We have negative 1 over 3. And let's fill everything else out. We'll have y equals negative 1/3 x plus 1. Part A. So part A is saying y is 2. So go to where y is 2. Y is 2 is right here. Then you just draw a line that goes through the axis. So we have to go through the axis. If I drew the line like this, am I going through the axis? No, I'm on it. We have to go through the axis. And there we go, we're done. Alright, B is saying x is negative 3. So we're going to go to where x is negative 3. And same thing, we need to go draw a line that goes through the axis. So that's why I draw it up and down. So if I drew it this way, you see how it's on the axis? That's not through it. We need to go through the axis. Dependent and independent variables. In graphing the equation in this section, we labeled the horizontal axis the x-axis and the vertical axis the y-axis. For each equation, we can determine values for y by substituting values of x. So meaning we plug in x and we get y. That's what we did for the t-chart. Since the value of y depends on the value of x, we refer to y as the dependent variable, x as the independent variable. We label the vertical axis with the dependent variable and the horizontal axis with the independent variable. Meaning, we have to plug in x to get y, right? So without x, there is no y. So y is dependent on x. Without your mom, there is no you. You are dependent on your mom. That's the same meaning.